have a low panel discussion. So I will now present the final presentation of today. With no further ado, I present to you Dr. Christian Johansson, CTO at Noda Intelligent Systems. Dr. Johansson is a Star Wars fan with a golden heart. Right. On his spare time, he is part of the 501 Imperial Legion and dresses up as a screen-accurate Star Wars figure to raise funds for charities.
Yes, thank you very much.
Thank you.
So I have 15 minutes now to talk about Star Wars, was it? No? Yeah? Well, okay, I don't know if this is actually good to mention in a work context or not. But anyway, okay. So we're going to talk a bit about tying the knot between grid operators and the customers. And the way we are doing it is through using active energy services. I know that a lot of this discussions today has been about what we would like to do, but hasn't really been a lot of discussions about how I actually do it in practice. So and this is something, yeah, here's the thing here. Like a lightsaber, really. Okay. Here we go. Noda, just to give you a short recap of what Noda is doing, we are a research-based spin-off founded in 2005. We do a lot of research and innovation work based on computer science and artificial intelligence. And then we try to apply this in energy systems of different sorts. We work mainly in Sweden, but we also have some work in different other countries. I think the main point of what we're trying to do is to create these sustainable energy systems. And obviously, we're a small company. We can't do this all by ourselves. So we work with grid operators and energy companies to try to realize these things. But there are three main things that we focus on, that kind of the leading words for us. And one is obviously to enable business. You don't want to do things that you can't make any money from. And I think that goes for most of the grid operators we're working with. However, you also have the second part, which is decreasing environmental impact, and which is becoming more and more important, both for the grid operators, but also for the building owners involved in this, and also basically everyone involved in society these days. And the last point here is also something that we try to focus quite a lot on, especially when it comes to district heating, because that's kind of a core part of district heating, that you ensure quality of service that always works. You know, you want to do it as efficient as possible. You want to save money or make money. You want to decrease environmental impact, but you also want to ensure quality of service, right? I think you can all agree on this. So, from our point of view, district heating is really, I mean, if we're going to build a smart city, then you will have to use district heating as a backbone. There's so much potential in the district heating grid and also district cooling. And this is, in my mind, a cornerstone of the future sustainable energy systems. There's so much potential that you can actually extract from a district heating system, which I think we've seen in many examples during the day here today. And this is something that we can also continue to build on. I think it's quite interesting, the potential that you can actually use as in kind of the infrastructure that you build these renewable cities around. I mean, from our perspective, we look at district heating and cooling as a kind of the basis where you can create this thermal flexibility. And this flexibility is something that you can actually use to optimize the whole production. You can also use it to include, for example, surplus heat, excess heat, and so on in the grids, cogeneration, CHPs, to optimize this behavior. Integrate with electricity. We're talking a bit about this today, primarily heat pumps of different sorts. And then also renewable heat of different sorts, biomass and so on, that you can use. And all this is being enabled through the district heating network. So, what is the problem here? Why isn't this really being done at the moment? So, I think one problem that we kind of focus on, I mean, there are many issues in this situation, but one focus point for us is that we're trying to look at the concept of the district heating being demand-driven. And a lot of the optimization that you see is not focused on the demand. You focus on production, distribution, obviously, because this is what you can control as a grid operator. But the whole system is demand-driven. So if you want to optimize this whole thing, one way or another, you need to address the demand. You need to control the demand. But you're not in control of the demand. That's a bit of a problem then. District heating in general also has some issues here. And I think district heating as a concept has to become more competitive. District heating companies need to be more on their toes when they talk to their customers, when they kind of include people in the cities. Because heat pumps and other heating sources are becoming more increasingly competitive. And especially in a situation in Sweden where you have a very mature market, it's not so much about getting new customers as much as keeping the old ones. You also have other issues here like the biomass. It's something that we in Sweden has helped us to kind of make a transition from fossil fuels in district heating to a very renewable production systems that we use now. But I mean, biomass, well, this is also increasing in price. Another thing that we use a lot in Sweden is incineration of waste. But this is also a value in itself, and other parts of the industry are also recognizing this. So that's an issue for district heating. And also, as we go towards a more circular economy, where people just generally recycling, there's less and less waste. At least in theory in the future. There's still quite a lot. And then the last thing I would like to mention about the problems here, and this is more of a technical problem. You have this complex duality, which I normally talk about. You don't see that in power grids so much because it's kind of more on and off behavior. But in district heating, in general, in thermal processes, you have two parts, this duality. You have this very fast processes, which is from the hydraulics, you know. It's a very fast process. If you're a pressure head through a district heating system or underwater moves by the speed of sound. I nearly said lights, but then things would probably explode. But it's a very fast process. But then on the other hand, you have the thermal propagation in district heating systems, which is, someone mentioned, 6 hours in Lund. And this depends on outer temperature and so on, but it's a very slow process compared to the hydraulics. And you need to combine these two things if you want to optimize the whole system, which is not really always straightforward. So, this is one of the things that I'm going to come to the end here. How do you do these things? And the first step is to stop referring to your customers as load points. This is something I think that the whole district heating company or the industry needs to become better at talking to their customers. These are people that are paying your bills, basically. So, and they are not load points. It might sound a bit stupid just looking at it like this, but I think it's a very crucial point of the maturity of the district heating industry. The other thing you can do is what we call vertical optimization. You look at the whole system in one concept. You have distribution of production, distribution and consumption. These are all the technical parts, but then you also add all the stakeholders involved in this. You have obviously the grid operators, a lot of people in the grid operators. You also have all the people involved in both production and distribution. You have the building owners. You have companies doing maintenance for the building owners. You have tenants and people renting the flats and also the offices in the buildings and so on. So there's so many stakeholders, and all of these need to be included if you want to kind of optimize the whole system. So since we have vertical, we also need horizontal optimization. This is, as I mentioned a bit before, where you can kind of use district heating as the basis to create a sustainable city. And this is, for example, where you can combine it with the power grid. We talk about the problems that we see in the future with the power grids is that it becomes more and more volatile. So, which you can see in the spot price markets. And there are different ways to use district heating as a kind of buffer or thermal flexibility to use to manage these things. So that's a way to kind of increase the value of district heating. I think in Sweden, we have a lot of district heating, so we know about these things more or less okay. But I think from European scale, we need to really talk more about district heating as a concept and what it can do to create a sustainable city. So to get a bit more into detail, how you can actually create a system to do these things. We have a system that we've been developing through different types of European Union projects, innovation, and also our own research about how you basically do demand-side management and how you combine this into a system that can also optimize production and distribution. And there are three different parts of this. I mean, you have to look at the peak load management, which is still part of most grids. Then you have to look at the base load, biomass boilers normally, whatever you're using, excess heat and so on. And then you have and this is the crucial part here, is that you have a last level here, which is the service level. We call it service level. You can call it something else if you want. But this is a level that connects the grid optimizer with the consumer optimization, right? First of all, these kind of systems can also be included in the things that we talked about earlier today, about supply temperature optimization or financial optimization at the production site. And then you can use these kind of system as a buffer that you take control of the demand. Since it's a demand-driven system, this gives you a lot of flexibility to kind of optimize the whole process, production and distribution. And also there's a lot of one thing that you can use as without even, at this point we haven't even included the customers yet. So at this point, we're just controlling the grid, we're controlling the substations, and we're collecting data here. We have primary site data. This is from the heat meters, basically. And there's a lot of information here. I think Sarah mentioned something from, there you are, how you do analytics based on primary site data, for example. There's a lot of, I nearly fell off the stage. There's a lot of data. But the crucial part here is not just to look at the data. You also need to look at what you can do with the data. And what you can do with the data is transform it, refine it into information. And this information is something that humans can use. Humans are very, very bad at looking at data and relating to data. So you need to transform it into information and knowledge. So, and this is the next step here, where you kind of combine these things into a system that the building owner can use. And there are a lot of different types of building owners, and there are different types of things that drives them, right? Normally, when you have these kind of active energy services that we work with, then people focus on saving energy. But if you look at the districts, a lot of district heating systems have tariffs which not just relate to the amount of energy they're using, but it also relates to how they use this energy, when they use this energy, and how they use the flow, and the temperatures, and the power demand of the buildings. So you also have to take this into account. And if you use that, then you can use this as a tool to activate these building owners, right? Also, you can add value by including the indoor climate, for example. We also mentioned this earlier today here, that people need information about what's going on in the buildings. Why are they doing these things? It's not just about saving energy. It's not just about saving money, but it's also about understanding how the buildings are used, especially if you have commercial buildings. Their primary driver for doing things like this, if you as a grid operator want to convince building owners who own commercial buildings, you need to look at indoor climate optimization also, because this is what they are selling to their customers. This is a driver for them. And also in this system here, you add the secondary side, and this is how you you diagnose the things. Then you go from the primary side. This is where you can detect faults. You add secondary side, you can diagnose things. Then you add also indoor climate. You can do even more better analysis of what's going on in the building. And another thing which I would like to add to your list is also to quantify the benefits of doing things also, because that's a crucial part when you go to your customer and try to convince them to do these things. So this is kind of an overview and a structure of how you build these things. And this is something that we've been testing in several different projects I mentioned, but also in commercial projects in different grids in Sweden, but also in some other countries. So this actually works, and it provides some kind of a platform, a process, how to approach your customers, how to talk with them. You don't approach your customers with data, but you give them information, knowledge, and you give them, when you come with a very active pricing tariff, you also give them a tool to react to this same pricing tariff. This is a very powerful concept when you put it all together. Thank you.
Thank you,
Oh.
Christian. Oh,
I forgot. Thank you very much for a great presentation. I would like to see if there are any questions in the audience for Christian. Well, then I get to ask a question again.
Which about Star Wars.
About Star Wars. Let's see. I was actually wanted to know a bit more about you spoke about customers. You mentioned it quite a number of times during this presentation, and it's obviously very, very important. Do you see that it is being done more, or do you still see challenges in that? Is there more to do, and what's the road ahead, do you think? What's your recommendations?
Well, there's a lot of things being done, and I think a lot of this is fueled by digitalization now that's happening all around in different district heating grids. So there's a lot of this data being collected, and now the next step is also to use this data in a good way, and also to, which I like to do, is to use this data to create information, also because you want to have communicate with your customers. You need to fill this communication channel with something, not just you used so and so much energy this month and you need to pay us this much euros, but also something about their substation. Or it can be ways to visualize what's going on, not just energy-wise, but also environmental-wise and so on. A lot of building owners they want to save money as everyone else, but they're also interested in sustainability issues, and especially larger building owners and building owners with commercial buildings, because, for example, as I mentioned before, they're selling indoor climates, and their clients in turn they normally have these sustainability goals. And if you as a building owner can help them with this, then you're onto something good. And as a grid operator, then you can supply this to the building owners. It kind of trickles down.
Yeah. So it's on many levels, and it has many different ways of, that positive, what do you call it? Reasons for doing it.
Yeah. Well, of course.
Mm. All right.
Okay.
Another hand for Dr. Johansson. Woo! Thank you so much. All right.